Sabyasachi. Uh, Please kindly go through once that LMS and you can see the documentation and the upload. You can see some more examples on collision. There is something like recoiling, ball recoiling after it is colliding with a wall or boundaries. I'm sharing you the entire screen. I think you are seeing the screen. Am I audible? Am I audible? Suresh sir. Vandanapu Suresh sir.
Yes, yes, you are audible, Dr. Sri Harsha.
Okay,
Yeah, intern Sinchana, can you confirm everyone is there in the class?
Yes, ma'am. I'll drop a message now.
5 people are there, I think so, of the class.
Those who are in the class, can you raise your hand?
The file is uploaded, sir.
Only two? Two have come out so far. So let me start the coding and just follow. Now we are going to see the example of the ball which hits onto the balls and changes the direction of recoiling. Moves at random. So we also choose a package called as random. Continue type and see that. So this is a program which is for studying the recoiling of ball when hitting the or boundaries of the ball. Right. Right. Wall, which is going to be a wall. Okay. The 6 points borderline. Ah, this is a program. Will recoil the wall into different directions, random directions. And there are, see the trails of walls. Recalling direction is not. Type it in the system. You can check it now. can type it in the system and check it now. Check the result if you get the same. Actually here the ball which trails will recoil in different directions as it hits the borders or boundaries. We are changing the direction of recoiling. It goes through the borders. Yeah. What is this here is the face of the robot is moving through the borders, and when you press, see here in the coding what we have given, left and right are given. The left and right are given. What this left and right will do is they are rotating the direction. They are rotating the direction. They are rotating the direction of the ball. Balls move with the trail. And it is recoiling as per you press left and right buttons. So changing the ball direction when it reaches the boundaries, or you can also change the direction of the ball as you press the left and right arrow keys. As you press the left and right arrow keys, you can also change the directions. Just check it once. The code is pasted in the chat box. Just check it. Yes, Praveen sir, you have raised the hand. Praveen sir, raised hand. Okay. Please, now you go to the Python idle, copy paste the code which is given in the chat box, execute that step by step, and check the result, and please update me the result. Meanwhile, we'll come into the other program like motion planning program also now. Yeah, we will now see the program where the robot can move between the coordinates. You can check in your LMS. There is a material given plus A star algorithm. You can also go through that. Just now we will be having the other discussion on this. So right now you just implement this. You execute the program. After this execution of the program, we will go into the program which can move the robot between the two coordinates. After that, we will go to the A star algorithm. I hope you have executed the program. Please indicate me that you have executed the program. Raise your hands. Wonderful. It has been executed. See that left and right arrow keys are the direction changes where when it recoils the wall, you can change the directions and the trails also remain in the same path. Yes. Sabishachi Sengupta, Bharadwaj Sripada, Purushant Murthy, you have done good job. Executed the programs. Let me know the other people also who are executing. Yashwant, Suresh, Vandanappa Suresh. Yeah, only 3 people have responded so far. The others, you can just copy paste from the chat box and run this program also in the Python idle. You could do that. Okay. Let me go into the other program. The program for moving the robot between the two coordinates. Between two coordinates. Moving the robot between two coordinates. Required to compute the distance and we execute here certain mathematical functions. So it is also required to include, it is also required to include mathematics, a math package. And we have a game initialized board simulation board starts. The first coordinates are these 60 comma x coordinate, and here the abscissa and the ordinate of the coordinates are given here. Okay. That means the object moves from 60 comma 60 to 140 comma 140, and then 140 comma 60 to 60 comma 140. And the robots height and width are 10 comma 10 to unit speed, and the current location of this is defined as location. A counter is defined here for the current location. So starts the simulation. The event handler. Now location where you should start the object is given as the xy coordinates. The current xy coordinates are given. Start, and the end coordinates are last coordinates, which you will get it by the modulus of the length of x. The distance between the x and previous position this position for x and y are calculated like this. A distance formula, hypotenuse of, so math dot hypotenuse of dx comma dy. Hypotenuse of dx comma dy is computed in the distance. If the distance is more than the expected unit of speed, then position with the same distance of the multiplication. To multiply this, automatically it comes like this. Okay. Then else last position. current I is equal to current I. And this will fill both both the blue color locations of 0 and the width and height there is a problem here, just we have to rectify. Yes. Moving between coordinates is that. From these coordinates 60, 60, 140, 140, and then 140, 60, 60, 140. And as we have given 60 milliseconds, it may have appeared that that has been random cost value. So what is done here is the starting location is taken, the ending location is taken, and the distance is computed. The distance value is computed between the 2 points, and if the distance is more than speed, then the position is computed. Otherwise, the position is all, and it closes the movement. Okay, if it is 0. Four points, and then up. Okay. This is how, see, this is moving between the points on the hypotenuse of the shape, which is derived from the points existing. So we are using here this method called as hypotenuse. Yes. So here what we have done is a path is set up. On the path, we have allowed an object to move from each and every coordinate with a speed of unit, with a speed of unit speed. Of course, here the height we have given as 10 by 10. You may also try it as something like 40 by 40 or something else. Okay. Like this 40 by 40, you may see it more clearly, because already we have 60 by 60 means you will not find much resolution of moving the object on the board, right? So you may give more number of coordinates also if you wish here. So it moves from 60 to 60 to 140 to 140 as a diagonal, and then from here 60 to 140, and then 60 to 140 once again, like this. 60 to 140 x comma y. Okay, right? Check it once with 40 comma 40. You'll understand again. Yes. Yes. And once again, you can give the last coordinate as the first coordinate, so that it will come back again, and the first coordinates. Okay. Let us dare giving like this, comma 140. Wait for some time. Let me see whether it comes back or not. You can check it this way. The other coordinate set. Yes. Did you notice that the movement of the box in the given coordinates? Check it by giving more coordinates and see the result. Run it with run this with a different set of coordinates and check the result. Let me know the status. Now the code is in the chat box. You can please take it out and copy paste it. Change the coordinates and let me know the coordinates that what you have experimented on this. Yeah, what is the status? Any one of you have executed this program? Please raise your hands if you have executed the program. We will go into the other one, which will move an object around like a circular path. Yeah, wonderful. You have done that. Now let us see the same program which can work for the circular path. Assuming that here we won't be computing any kind of what is called the hypotenuse, but simply we move from the locations. There is a method in this called as move method. We will write a move method so that the move method will move. The move method will move the object. Let there be screen and clock. Let there be the screen and clock here, and this rest of things will be changing. This program now we will have the x and y coordinates as some coordinates of 430 and 630. I is now enhanced to 600. Okay. Height is not possible, so we will take it as 600 by 750. Take it as 600 by 750. Then xy coordinates 430 by 630. Now we will identify the corner points of this. 600 by 750 as what is called the first point is 430 by 6. We are moving clockwise, so the x reduces. Let us say it is 30 by. Then the same 30 by 30. And clockwise, we are moving clockwise. The last one is, as we have only 4 points. The 4 corner points are given, and the speed is equal to true while 1. Event in by x comma y is equal to comma y comma next position. Yes. We maintain a next position index also, and we write a method called as now move method. Okay, what is next position index? Next position, next position index is 1. Now moves the object at x comma y with the speed of 1 to all the corner points and with the next position. We have here 1, 2, 3, 4, 5 arguments in the move function. Try to write a function here. F move x comma y comma speed ts means points circle underscore direction circular direction game dot math dot if circle underscore direction and the speed. The direction speed described and a position is computed. Variable we have not declared anywhere else. Now only we are declaring game dot x will return comma I. X comma y comma I. That's all. This dot dot and let the clock tick for every Able to see this, everybody? So here the objective is to move an object to in a circular fashion, and here we have given the points, and this is a path, a pre-specified path. Okay, and in the pre-specified path we are about to move, and here is that on the circle, on the board we are drawing a circle at x comma y comma 20. Okay, we are drawing a circle at this position.
Yes, sir. The clock, can you write down the title of the program from where the program is beginning?
Okay. Shall I put it in the comments here?
Yeah, yeah, so that it becomes easier for them also.
In a circular. Okay. In coordinate. Yeah. So let's run and see. Where coordinate system 630, 430, 630, 330, 630, 30, 30, 430, 30 is right. That is right. Speed is equal to, let us do. Oh, maybe minor mistake somewhere. Let us see that x comma y speed comma points comma I circular direction 5 game per math or vector 2 of points of this minus x comma y circular direction of length is less than speed comma y is equal to I plus 1 mod length of points circle score is not minus this is so the robo is now moving circularly. It is rotating. It is moving along all the boundaries. Okay. Only between the set points the robo is moving. Did you identify this? We have given 4 points. Only on the 4 points. The 4 points what we have given. Okay. Now the robo is approaching 30, 30. Now it is 430, 20. Now it is going to 430, 630 and 30, 630. Okay, and the speed is given as 2 milliseconds. 2 milliseconds is the speed, the time of the clock tick. What is given is the speed here. Okay. Yeah. Did you notice that the points are these 4? Okay. And between these 4 points, it is circularly moving, touching all these points. Here the false, the loop is iteration. Further, it will stop the program after you close the button. Okay. Please try this robo motion planning in a circular path using the coordinates. So we are giving the coordinates that they will form an enclosed shape like rectangle or a circle or whatever. You may also give here more number of parameters, more number of coordinates here, and you can say you can give the coordinates. Here we have given the coordinates of a rectangle, the four corners of the rectangle. You may give the corners of a hexagon, corners of a octagon. Okay, you can give corners of any other polynomial shape, polygonal shape, and you can assign that as an array here, and we can allow the object to move along all these points as a circle path. So actually we cannot move as in a circle path. We do not know the points on the locus of a circle. Okay, it is not possible for knowing the points of locus of a circle. Only that we have a mathematical derivation that we can test whether a given point is on the locus of a circle with the given center point and a radius, but not for, we cannot determine, we cannot decide that what are the points available on the locus of circle, because we should know the granularity of the Cartesian plane and the center point of the circle, radius of the circle. All this there should be some kind of a proper granular metrics for this circle. Then only we will be able to know that each and every point on the locus of the circle. As that is not known, what we do is we take a enclosed shape and we take all the corners, and we will go for a multigonal diagram where there will be some kind of 24 sides, 60 sides quadrilateral, 60 sides quadrilateral enclosed, and the coordinates of each and every side can be given, and all these coordinates given in the array will allow the object to move exactly like a circular also. Okay, right. You please try this. This is about the robo planning on coordinates. Okay, I am copying this into the chat box, and please try these ones. Please try this program and let me know the difficulties where you have struck, and we'll understand the solution how to give out. Yes. How many of you have done so far? Only 5 people. Last session we have seen one gentleman, Rajanna, has not come to this session. Sinchna madam, Rajanna did not turn up.
No, sir.
You are
He's
there?
not present today. He's not present today.
Okay, okay.
Yes, sir.
Let us say another example considering the configuration space and as a broader one, and the topological space is a rectangle, it's a triangle. Rubber motion planning in a triangular topological space. Okay. Planning in a triangular topological space. So where we have methods like to draw a triangle, we have a draw triangle method. A and B point. Use by game dot draw on which we can draw on the board, and the set of points how we can draw a rectangle, a triangle on the board. Okay, and we line method which returns the Euclidean distance. You know the Euclidean distance. X2 minus x1 whole square plus y2 minus y1 whole square, that's apt. Here point A has got two parameters, that is point A of 0 and point A of 1, that is xy. Okay, here we say uh, the formula and then let us go into that. And BC and CA. Perimeter of a triangle. The area of a triangle with these distances is S into S minus AB into S minus BC into S minus CA. That's simple. SQRT of that thing. Okay. Okay. Then we are reading the points back. And the formula for this is into and return value of the argument. Return in the function. Okay. So what we have done is we have just written functions which are the prerequisites for this program. So here we are going to do some kind of motion planning and in the triangular topological space. Is equal to file 2. Is equal to game dot com. Six and mouse. Now the triangle based upon A and compute the area for yeah A comma B comma internal three triangles of the triangles with respect to the processor array are taken based upon the mouse position which is placed in the triangle. Based upon the mouse position which is placed in the within the triangle, from that position the other three triangles are deduced as TA, TB and TC, which are trigonometric triangles which are within the triangle. And the sum of the trigonometric triangles minus area must be less than or equal to 0.001. Then the color will be 0, 255, 0. Otherwise, the color is white. That means what? When we collide into a triangular space during the motion planning, when you collide into the triangular space and with a threshold of 0.001 tolerance, the triangle will glow with the color of 0, 255, 0. That is what a green color. Otherwise, it will be a white color. That is a coding. That is the object. A plus TB less than color is can this and update this. So while doing this robo motion planning, if the mouse pointer moves into the triangle, what is done? The obstacle detection within the triangular area. The type error. But 4 were given. Draw triangle has taken 3 parameters, but 4 were given. Also. Color is not defined. It even color. Even if I say here yes, it will not respond. Yes, color. Wherever there is a color, we should go for or otherwise zero. SQRT is not defined. We have to import math. Just by giving this may not work. From so there is a rectangle now. Okay. So when you move to the rectangular zone, not even in the border. The triangle, sorry, triangle. This is a triangle. Here there is a value error. S is equal to turn. SQRT of S into S minus AB, S into S minus BC, S into S minus CA. You may have to give here some part. Okay. All the 3 sides of a triangle. When you get into this, yeah. So you check here the triangular base of the robo. Here, this is the triangular base of the robo. When something reaches the object, when this mouse pointer reaches this object here, triangular shape, only on the sides of the triangle it is white. And if it enters into the triangular, touches it, it becomes green. Oh, correct, no problem. Yes, so triangular topological space. A triangular topological space. When the mouse moves into the code, this code, and let me know the result that how many of you have executed this program and study it in detail and tell me the result after you have executed the program. Yeah, Suresh Gopati, yeah, executed. Wonderful. The others also can execute and show me. And meanwhile, we shall, yeah, Savi Sachis and Gupta also has executed. Others also can execute and please report to me. Now the time is 5:35, 3:35. We will come back by 3:40. 5 minutes break. She'll have a break for 5 minutes and we'll come back at 3:40. Okay. Thank you.
Okay, sir.
Sinchana, Dr. Sriharsha? Is it that I am not able to hear anything?
No, sir. No, ma'am. It's a break. It's a break.
Oh, it's a
5 minutes. Yes, yes.
No.
After the break, now we'll get into the A star algorithm. Okay. It is in our LMS. It is already stored in the LMS. That A star algorithm. I will be just discussing about the performance of the A star algorithm, which will be useful for path identification. In artificial intelligence, the A star algorithm is prominently used in order to identify the optimal path from the source to the destination or source to the goal or objective. Actually, this A star algorithm, which is derived from the breadth first search algorithm, and this breadth first search algorithm is uh, revised into the optimal paths and optimal costs of the distances. Yeah, this here. Okay, the optimal paths from source to destination is obtained using the open set intermediate points, and the selection of open set intermediate points is based upon the cost, how the uh, originating point will derive based upon the underestimates and overestimates of the distances between the open points to destination and open points to the source. Okay, that anyway, that is application of the SR algorithm. And here is this, you can see in a blocked environment. Yes, in a blocked in a environment which has blocks, and the source and destination are identified, and the path is en route with all the different kinds of blocks, where a city block distance is computed or a Manhattan distance is computed rather than an Euclidean distance. Okay, an Euclidean distance will be a direct distance which is from the source to destination in the Cartesian plane, which has a fixed slope, where the Manhattan distance or city block distance will not have any slope, but it occupies that, or it covers the number of blocks which are on the route of reaching the destination. And how many number of blocks will reach that, how many number of blocks will be occupied for setting up the path from source to destination is the basic cost of the path. Okay, as less as number of blocks should be set up from source to destination, and for this to enunciate the less number of blocks from the less number of blocks in the path, we use the A star algorithm, A star or A search algorithm. Okay, and this has three important properties. The three important properties are the G, H, and F. Okay, and G is the property which is used to compute the cost of moving from initial cell to the current cell. Basically, it is sum of all the cells that have been visited since leaving the cell. And also, overestimate and underestimate also can be computed for this in order to test the admissibility of the A star algorithm. And H is another heuristic value. The heuristic value is either a value which is maximum value or a minimum value. We will test for all the guessed values or threshold values of the H, and we will say among the set of values of the H, which value will determine the minimum cost of the path from source to objective, source to the goal. Okay, and F is the function finally which will determine the uh, path decision based upon the F value. The F value, if F value is less means then it is a least cost path, and if F value is more means it is a high cost path. Okay, And this is what we have basically the A-star algorithm, and we'll get into the concept of what is called the code which is associated with this A-star algorithm. Here is the A-star algorithm code, where you have here a box. A box class is defined. As I told you, this is computing the city block distance or Manhattan distance, and number of blocks which come around into the path counts the cost of the path. Okay, and this is the A-star algorithm. Typically, this A-star algorithm is used in the maze problem solving. Okay, so when a robot is allowed into a particular configuration space, which is a maze, and there are so many obstacles and there are so many paths possibilities which to reach the destination, and where the robot should move with less number of blocks covered during the path. Okay, and in order to do this, what is done is the A-star algorithm is used. So here the A-star algorithm is given with the maze as input, start point as the input, and end point as the input. So when a maze start point and end point are given, this algorithm will determine the paths or the coordinates. Okay, and here is the board which contains the maze. Here is the board which contains the maze. Okay, this is the maze. Right, and here we have a very minimum constrained maze where we have a single wall and there is an entry point. There is a single wall and there is a single entry point. Okay, and these are all the free spaces. These are all the free points. These are all the free points. All the ones are the points which are obstacles. All the ones are the obstacles and zeros are the free points. Starting at 0, 0, that is here, and ending to the 6, 6, that is 1, 2, 3, 4, 5, 6, and here 1, 2, 3, 4, 5, 6, and here. Okay, so to reach from here to here, what are the points that we have to cover? So the minimum number of points that have to be covered to reach from this location to this location will be computed using the A-star algorithm. Okay, and here is this. These are the points. The points at 0, 0. Just look at this here. Just look at this here. This may be experimented graphically also, but there is a glitch here in my code. That's why I could not execute. So let us see here. See, this is the starting point 0, 1, 0, 0, and there is 1, 1, and there is 2, 2, and there is 3, 3, and there is again 4, 3, 3, 0, 0, 1, 1, 2, 2, 3, 3, and 4, 3, and then 5, 4. Directly we got 4, 3, and 5, 4, and then 6, 5. 3, 3, 4, 3, 5, 4, 6, 5, and 6, 6. Yeah, here is 6, 6. So we reach at this point by means of covering all these points like this. Okay, by means of covering all these points like this, we reach the destination. Okay, the algorithm has derived this kind of points. The A-star algorithm derived this kind of points in order to reach the destination. Let us see an animation-oriented image representation for the A-star algorithm. And meanwhile, let me copy this to the chat box. You may try this example. The code for the A-star algorithm, and meanwhile you can look into this which I show you now. The different sources reaching the destination covering the city block distance using the A-star algorithm. Here is this. Just double click on this to execute this. This code also has been given in the LMS. You can just try it once if you have that. Okay. So this is the navigation program where you have here instructions to work on the middle mouse button also, but I don't have middle mouse button. We have a mouse wheel, and we can use left mouse button and right mouse button and a space bar. Okay. So you can see, you can look into this instruction. This program is a Python program which is written for simulating the A-star algorithm from many source points to the single source point. Okay. Left mouse is to add the target. Right mouse is an agent where it is that is used to move to the location, and space bar to start the navigation, and R, small r, to reset the navigation. Okay. So we can use here left mouse to set the target, and here right mouse to set the agent, and give a space bar. The path is drawn and the movement is gone. Okay, right. See, when you have obstacles, it's a different case. Here there is no obstacle and there are free. As they are free, when you give here look at this. A minimum cost plan is derived for all the agents which are moving around. Okay, let us reset this, and now let us see the different kinds of targets. Yeah, just look at this. I get it out that I am sharing the screen. Are you able to see the screen?
No.
Is
Yes,
there anything
what
shown on?
document? What document we are seeing?
Oh my goodness. Here, are you able to see the screen?
Yes.
Okay. Let us see here the simulation of the S algorithm for the single destination various agents moving along in the city block distance, the configuration space which is defined with city block distance method. You have a doubt that we have this kind of points, we have these kind of points, and these kind of points move to the location with less cost. Okay. So you have not seen the result of the A-star algorithm also. Let me show you that. So here this is the A-star algorithm and there are boxes. The class box is defined and number of boxes are computed in the grid. And here is that what we have. I think now you are able to see this array. This is the board of configuration space where you have all the zeros and ones. All the zeros are the free spaces and ones are the obstacles. Okay. And when you happen to start from 0, 0 to 6, 6, that is 6 and then 6. So you want to end here and you want to start here. Okay. When you want to end here and start here, what will be the number of blocks that are covered to reach the destination? Okay. Either it should come in this direction or I should come into this direction, or it may also come like this and join here. I think now you are able to see the array. Okay. And but what happens? Let us see after executing this program. we get the array like this: 0, 0, 1, 1, 2, 2. Just look at here. Please look at here. 0, 0, 1, 1, 2, 2, 3, 3, and then 4, 3, and then 5, 4, and then 6, 5, and then 6, 6. Okay, 6, 6 is this from 0, 0. Okay, so it moves like this. Okay, so to reach this destination, the optimum paths chosen is in this direction. The minimum number of blocks are chosen in the A-star algorithm. Okay, so change the endpoints here and check out the different types of paths that can be achieved here: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, you can do very well 6, 9. Up to 6, 9, you can try this algorithm. It generates the points like this. To reach 6, 9, all these are up to 6, 5. Then you have 6, 7, 6, 8, and 6, 9. Okay, and you may also give any other point here, which is 0, 1, 2, 3, 4, 5, 6, 0, 6. Let us try giving here a 0, 6 and check out how the points are derived. So when the points are not derived means what? There is no path possibility to reach the location because there is an obstacle, and where this will not allow to go to that location. Or just give here 6, 0. For 6, 0, there is a possibility. It is allowing to derive the path. Okay, it is 0, 0, 1, 0, 2, 0, 3, 0. Oh, it is like this: 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0.
How 0,6 got the obstacle? Could you please explain
Yes.
that thing?
Yes.
How 0,6? How 0,6 got the obstacle? Why not 0,6?
This one is an obstacle here. That is the reason why. Here, this is a 0, 6. This one is an obstacle.
0, 1, 2, 3,
So it has to come like this. It is a very costly thing. Just a second.
Break. Yeah. First thing in break. What is the object? There it is. All marking here.
Yes. You got it out. How 0, 6 has got obstacle? That is a 1, and there is no least cost path for this 0, 6 because the number of blocks available here are only 4, and we are the maximum paths. Okay, the open set contains only 4 points, but it takes more number of points than the open set. So when it is taking more number of points than the open set, then there is no least cost path. So that's the reason why the ASR algorithm cannot generate a path here. Okay, see, it has to generate the points from the open set, and the points in the path should be subset of the open set. Okay, where here the points in the path will not be the subset of the open set, so there is no chance of getting a optimal cost or minimum cost path from 0, 0 to 0, 6. That's the reason here. Right? Is that okay? So you try it for other parameters, other values, other locations. and let me know the results that if you find any peculiarities in the result of the A-star algorithm. And do the simulation which I have sent in the LMS. You can try the simulation right now. Yes, are you able to see the simulation? Okay, you can set the destination points and the source points. The point from where you start, and you have to reach this location. And press the space bar. The city block distance what is covered here with the Manhattan city block distance, which will not go in a diagonal direction. The less number of the city blocks are covered. Okay, you can reset it and see that. Suppose if you put it here right now, the path which is chosen will be in this direction compared to this direction in this way. Okay, and if you start it like this and if you end up here like this, and now you can simulate the number of elements which go like this. If you understand here, the path is now reduced to another block. Okay, and you can check out here, a center point may reach the boundary point in this direction. Okay, so this is what we have A-star algorithm. You can execute the simulation and you can also execute the path of 6 by 6. 6 by 6 array is there. Okay, check it out now and let me know the result of the different impressions what you get from executing this program. Please check the different kinds of outputs with different kinds of inputs. Please try out the A-star algorithm. Okay, you have executed the Esther algorithm. Now let us see the rapid random trees algorithm, which is also used. See, in the A star algorithm, what is done is the number of blocks are known. The number of blocks are known in the given configuration space. A given configuration space, as the granularity is also known, the number of blocks to cover the path also will be known, and the open set is very definite here. The open set is definite. Okay, when the problem comes that the open set is not definite, it is indefinite, then the hierarchical approach of finding the paths from one location to other location with a given threshold will be employed, and a tree is generated. A random tree from the possible branch of a tree generated will be once again exploded, and number of trees are generated like random trees, and the last random tree will be the tree which will be reaching the destination. And like this, the random trees are generated rapidly between all the branches of the first tree. The initial tree starts from the originating station, and the number of branches when they emerge from each branch, again a tree is emerged randomly, and that is subsequently incremented. And meanwhile, the optimization is taken place that the branches which do not go in the angle or direction of the destination will not generate the random trees, and only the branches which goes into the direction of the destination will generate the random trees, and these random trees will apply to the path where the location will apply to the path where the destination will be obtained with very least search distances. Okay. Sir Praveen sir, you please mute that. You mute your. Please mute your phone, sir. Yeah, now I am getting into this showing the RRT. RRT algorithm. I'm getting into this. This is the RRT algorithm. Usually, how the robot can select the random paths. Just look at this here. Set the goal point. This is the goal point. And that is another point set. See the simulation of generating the rapid random trees. The number of trials are made. Number of trials are made from the origination point to the destination point, towards destination point, and any failure tree, any tree which is failure, which is not experiencing the optimal path or which is experiencing the obstacle during its path, will be again restarted. It will be again restarted. Now you can see in this rectangular board, all the points which are colored are the possible states of the sets of points which can give the scope to build the path from originating station to the destination. So almost all up to here the points have come. And if you leave it, it will take much time. It will take a lot of time to generate the paths. Okay, because of these obstacles. You have here two big obstacles. Because of these two obstacles, it is very difficult to generate the path. A difficult situation. Okay, where you can try on another level. Okay. Let us put here this a point and see goal reached. Okay, you can see here the goal reached. Problem. Okay, and for this also you can simply say the goal is reached. Takes number of iterations because of the orientation of the direction. So try some more points on this. Set a point here and set a point here. Goal is reached. Okay, I will give this file into the LMS so that it will be available to you. You can try for number of times. Okay, this RRT algorithm, I will give it in the LMS. You can try it in the right for number of times or so. Okay. Sinchana madam, please try to put this file in the LMS.
Sure, sir. Will you send it here or in WhatsApp, sir? Where will you send it, sir?
It
In
is
WhatsApp?
group in WhatsApp.
Okay, okay, sir.
Okay. And there is also another example of running the manual form of a star algorithm or manual form of detecting the path for a car like robo. So we have look at this. Can stop it. Presentation. This algorithm we tap it for only one time. The keystroke is given for one time tapping. The double tap means it will go continuation. So we should be very careful in this because the keyboards are very sensitive here, which will tapping means it is almost like long press. When there is a long press, it will take number of replications of the object. Okay. To give a gap between a press and a press so that we can allow this to move from this location to the destination through to move the car through here and this and this and here. Okay. Finding the path. Finding the path through the obstacles is possible with this. This is an autonomous robo where you just initiate the location, starting location, and move the direction. See the trailing green box, which is indicating. Trailing green box indicates what is called block in the city block distance. The blocks covered in the city blocks distance are shown in the trailing blocks of the car. Notice this. Block which is moving along with this. This is a manually operated A-star algorithm, which we can say, which will resolve a optimal path with a number of city blocks in the route, right? I will also ask Sinchana madam to share this file into the lesson LMS system. Okay.
Yes, sir.
This is entirely one single zip file because we have here the other dependent files also. So all has to be downloaded. So you copy this the entire zip file, compressed file, 13.kb something. Okay. Right. That is how today's session. And what I have planned is today about some theoretical concepts and then obstacle detection and then motion planning. After that, A star algorithm and some introduction about the RRT. These are the topics which I planned for discussion, and I hope I have discussed these points. And if you find anything which is not covered, you please let me know that we can cover the points to the entire fulfillment at least in the next session at least. Okay. Please come on with any kind of discussion. Thank you.
Thanks.
Yeah, please come on with any kind of discussion that we can go on.
Currently, I don't we have anything. We would go through code, and if we have some issues, we will just ping you on Teams.
Yes. Being in a PG, we can explore into several kinds of papers, articles, publishing. Okay, there is much scope of publishing articles in motion planning, manipulator motion planning or robo motion planning. Both they're having wide scope. And there are so many kinds of yeah, configuration space representations based upon the configuration space representations and the constraints and the geographical conditions. We can superimpose the configuration of the space with the geographical conditions, and we can analyze a new method. We can derive a new method of robo motion planning or manipulator motion planning also. There is a large scope of developing many ideas. Okay, and for us and at this PG level, we have a large scope of writing much number of papers, articles, of publishing good number of good indexed journals like Scopus, CSCI or SCI journals and so on. Right. Particularly again in the 3D planes, in the 3D when it comes to the configuration space of three-dimensional space, we have a lot of opportunities like terrain riding of robo. Okay, terrain riding of robo, and we have seen already in the morning PPT the different types of motions. Okay, different types of locomotions that the robo allows, walking. Okay, there are so many kinds of methods which I have discussed. Rolling, walking, hopping, metachronal motions, slithering, swimming, brachiating. These kind of various kinds of motions are there which can be allowed, and which are useful for different kinds of robots and different kinds of configuration spaces, right? So there is a wide scope of doing these things, and as well as the pathfinding also is a very important and interesting area where you can find good number of articles and this. Okay, as a PG student, you can very well do a systematic literature review on these kind of things. Since ages, there are so many papers. We don't need to refer to the number of papers in the ages. Okay, the recent 10 years pages you can refer and you can build a very good article and publish in a good journal like Scopus journals or SCI journals or ESCIs, so on. Okay, that will be a good idea. Anybody have any idea about publishing papers and working on the articles? Let me know this. Yes, yes. Please come on loudly. Yeah, Sabyasachi Sengupta.
Yes, sir. I think if you have any kind of say kind of papers that we can probably refer to get an understanding, and that will be great. Then probably we can check. I mean, if any journals or something that we want to probably contribute.
You want me to tell journal names?
I think topics. I think you were mentioning right some of the movement journals and all that,
Like
or some kind of papers, just to give us some idea. I mean, what we can
there
explore.
are so many Journal of Artificial Intelligence, ACM, Journal of Robotics. Again, that is also ACM. And in Hindavi, there are a good number of journals, Neuroscience and Robotics. And in MDPA, there are a good number of SCI journals. Uh, and there are some other journals like Grenze, Grenze group of journals are there. Okay, good number of like uh, American Journal of Robotics is there, which is also a good journal which we can. But the conflict arises that we should not be, see, we are computer science and engineering or data science and engineering or artificial intelligence professionals, and our fold of presenting the data about these artificial intelligence and robotics will be different from those who are in the mechanical actually. See, when we are from the mechanical background, we discuss about all the different mechanical operations, mechanical compositions, their velocities, parameters, properties, characteristics, built-in material, etc. So on. And that is a robotics of from the manufacturing point of view. But here, in as a part of AI, we understand that accomplishing the goal set by the robotics. So it's all that we do programming the robots to perform an action with an optimistic, with an optimal usage of resources, time, and the path, and so on. Okay, whatever that is. So in that regard, we have good journals on only on artificial intelligence. As of now, in the recent 5 years, only recent 5 years, when the Python has emerged into a gigantic perspective, the robotics has been merged with AI. Before that, robotics was not in the AI. It was only artificial intelligence, ancillary topic for the mechanical engineers, which they put into some robotics. But now, as AI has become completely programmable, these programmable activities can be deployed on the electronic and electromechanical robots. And now we have robotics with AI completely. So very, very trending and very essential topic for the future robotics with AI, and we will accomplish much more things. I don't know, wonderfully new things will come up. Uh, if you go back to the RUR, there is a drama I told you. There is an RUR drama. Okay. If you go into that, there are robots which do wars, and there are some robots which do kitchen work, and there are some robots which can do what's called carpentry, and there are robots. See, these are all electromechanical robots, electrical plus mechanical robots, where they are not programmed, of course. They are not programmed, okay? And they can be programmed by using this kind of artificial intelligence. Like, say, when it comes to the point of perception, I told you one of the aspect of the robot is perception, sensory perception. Okay, sensory perceptions. We have sensors, very varied kind of sensors are there, right? light sensor, light sensors, pressure sensors, smell sensors, reflection sensors, weight sensors, wetness, humidity sensors. Okay, even the vapor pressure sensors, which will also find out the smell, like gas smell or an effervescent smell or any incense smell. This kind of smells also can be tested. So like this, so many kinds of sensors are available. Okay, with these sensors, they convert the data into some GPIO boards and then to the programs of your Python, and we read the data and we represent the data and we control, we manipulate the data, we control the robots based upon the feedback given from these sensor devices. And it is also a kind of an artificial intelligence deployment on the robots. See, nowadays, this SOC has become, SOC means system on chip. Okay, the revolution of SOC has become more predominant in the aspects of implementation of robotics with AI. Okay, earlier when you talk about a system, the system is of very big size, like transistors, transformers, ballistic transistors, and so on. But nowadays the systems are not that kind. Okay, even on a fingertip, a nano size chip can be developed there with all the powerful uh, computation capacities, right? So with this, we can explore much into these. The robotics with AI can explore much into new more inventions. Okay, so when there is that kind of a wide superfluous scope in this robotics with AI, why not we write an article and publish a paper, very good papers. So for all these, the fundamental, the core and fundamental topic of this any kind of sophisticated robot is motion planning. Okay, motion planning is the first important thing, and the next important thing is that the detection of the paths, path finding. Okay, so if these two are well accomplished, then your goal is accomplished by any kind of robo on any kind of application. That's what I mean to say. Sen Gupta.
Sure, sir. Thanks for the insight.
Guru Shant Murthy, please come up, and Rakesh Kumar. Pavan. Sir,
What?
for
Yeah.
Vandana is only is visible here. Shankar, please come on. Shankar, please
No,
come on.
what you want means, I think so. Sabyasachi has asked you nearly all the things. But so, what you means? Could you please elaborate what you want to say? Means,
Yes, yes. Your voice is resound.
yeah, there's a network. There's a network issue at my end.
Okay, okay. Please come up now. It's clear.
Yeah, I'm saying Sabyasachi has nearly asked you all the query regarding the journals and the things to get that thing. So I think so. I'm okay for that.
Fine. Even not in the area of publishing journals, you can also become a very good hobbyist of becoming a robotics application, robotics enthusiast.
Robotic application and even a gaming thing means a small start in a gaming industry
I
also.
believe everybody have purchased Raspberry Pi.
No, I was trying to purchase,
It
but
is around 6,000 to 7,000 rupees in the Amazon.
the latest version is 6,000. But if you buy the Raspberry 3.0, it's nearly 4,500 with the
Yeah,
complete box.
there are Raspberry Pi 1.0 onwards are there. Zero, Raspberry Pi Zero is also there. Okay. There are so many Raspberry Pi boards where you can easily do Python programming using GPIO connections.
Yeah,
It's almost all a credit card size computer, that you can do connecting to an audio video device. Okay, we can, what do you call an audio sensor? Okay, an audio sensor. You can put this audio sensor in a meditation hall and detect the noise also. Okay,
right,
value
right.
of meditations and so on. Not
But
medication, meditation.
yeah,
Okay.
Auditor does the same thing, right? Even Auditor is more reliable, I would say, as compared to Raspberry Pi, because it gives you the flexibility to add the what to say your sockets and all those things. It gives you a complete device, separate
Yes,
device.
it's almost a complete PC.
Yeah.
Yeah.
Uh, Raspberry Pi is a bundled one, where even it's nearly done. It's like a small PC, but it doesn't allows you to do some multiple activities like
Yes.
robotics hand, robotic means movement. For
Yeah.
that, we require Arduino only.
Using Raspberry Pi, we can also even control a servo motor and a
Uh-huh.
series of servo motors. A series of servo motors can be controlled by Raspberry Pi using a Python program. And using a Python program, you can also control so many kinds of IoT operations can be done with the Raspberry Pi. And when you infuse any intelligence in these algorithms which are running the Python, executing on the Raspberry Pi operating system, they can even do an intelligent task of the IoT also. Like
If we have if we have one more session, additional session, and
possible.
you're buying a Raspberry Pi, so is it possible to means highlight how it works and how to means what to say? Well, at least a basic feature means how to work, because Arduino is a little complicated. Arduino is a simple one because what I have seen
Using Arduino is modular. Arduino is modular where you have to buy other bit chips or bit sets.
yeah,
Bit sets
exactly
are there. So many things like bit sets are there, or bit cards are there. You have to
right,
buy so many bit cards to operate on the Arduinos. Where
right,
that kind of risk and architectural complexity can be reduced by using Raspberry Pi because everything is in program, right? All that
right,
enough, you have to use a peripheral device connected to your GPIO devices or anything like say USB ports. You have two USB ports and one USB 3.0 port in the Raspberry Pi in the latest version, and we have GPIO 41 pins are there, 24 pin is there, and 40 pins also are there. Okay, accordingly, we can buy a sophisticated Raspberry Pi with a sufficient number of GPIO, and we can connect to any kind of peripheral devices, and we can operate them with a program simply using a Python. But when you come to the point of Arduino, Python programming kind of software programming is a bit difficult. Why? Because they are all dedicated to some kind of a task. Like we have bits for operating radio frequencies, and bits for operating infrared frequencies, bits for Bluetooth frequencies. Okay, there are so many bits available, and there are so many sensors devices which can be connected to the Arduino. So of course, that is very simple in architecture, but when you come to the application point, you have to integrate so many kinds of devices, and it becomes a complex to handle. And moreover, that is not a generic in nature. The application built in Arduino are not generic, whereas the applications which you built in Raspberry Pi, they are generic, where you can change the peripheral devices, and the program will run according to the devices also, because it's your software program, which is a Python program or whatever, or C++ program. It runs, it just communicates with the GPIO port, and it reads the data. So it is generic here. Whereas in the Arduino, it is not possible for a generic system. Is that right?
Mhm. Got you.
So on
So
practice,
are you
if
are
you
you going
become
to show
a
it next
hobbyist
time?
or enthusiast of this robotics, you can understand well about the philosophy of using Raspberry
I
Pi
know.
or
Yeah. Are you going to show it next time so that we can just purchase from what to say?
I'm trying to show it in the next. Using a Raspberry Pi, I will try to show operating a servo motor and sensors using what is
Actually,
called visual
purchase,
detectors.
yeah.
This I'm
If you're
planning actually
purchasing,
for next time.
yeah, if you're purchasing in bulk from actually from the Raspberry Pi owners, developers, we get it a little cheaper rate, because my company, ex company, had taken 20 thing for Metro. Okay, and so they were using I think the 2.0, 3.0 thing. So even had given some additional benefits to them.
Hmm.
Okay,
Yeah.
but yeah, we can do that thing. How are you going to bring the Raspberry Pi to your end to show?
Yeah, there is. I have all the versions of Raspberry Pis. We can work with cameras. We can work with servo motors. We can work with temperature and humidity sensors. I'm planning to do that. Next time we'll plan this.
Yeah, we wish that we should have one more lecture, not two more. Last lecture is then next lecture is the last lecture, if I'm not wrong.
Yes.
Yeah,
Yes.
if we had one more lecture, it would be much better.
Yeah, we will discuss with Praveen sir, and we will do this.
Yeah, sure, sure. I just try to purchase that thing. 3.0 is okay, right? Or should I buy the latest one?
That is your interest. I have it. If you want, you can purchase. You can work on it on. No problem.
I just check whether it's getting delivered in time. If it's getting delivered in time, then I'll purchase it because even I wanted it for my client also. So, so
Yeah, our request is like this, Srihari, just help us with one of the implementation, like Shankar and you are already discussing.
Yeah,
So
visual.
why don't you please help us
I'm
in
planning
case
to
we
put on
require?
visual detection.
Sorry.
Just a minute. Just a minute. Visual. Just a minute. Just a minute. Actually, I am planning to put one application with visual detection, that is, say, recognizing the object name. Okay, which includes what is called a Raspberry Pi, a camera. Okay, and in the Raspberry Pi, we have a Python shell, and in the Python shell, we import what is called the OpenCV. Using OpenCV, we will be able to communicate with the camera, and camera reads the image, and in the background, we have a dictionary of the data. Like in some XML form, and this dictionary of data will be compared with the red image from the camera, and that is matched, and it will identify the location in the image where is the buffalo. Okay, that is yeah. We give the XML form with the different parameters of an object which are in the image. Okay, and this particular object will be traced by the OpenCV Python artificial intelligence program, which is in the image which is captured by the camera. So this I have an application.
Okay. Okay. Yeah. In case we required, we
task
will
is
be
also given
in
in the
campus as well.
tutorial. What is prescribed for us at say, yeah, when the robo is drawn into a configuration space where there are a lot of objects thrown away, and the robo will move along all the locations of the configuration space and identify the objects in the configuration space, whether the object is a toy or not toy. This is also could be quite easily possible. Visual sensing Raspberry Pi.
Okay. Hello, am I audible?
Yeah, Shankar, audible.
Yeah. So you are saying that you would be detecting the what is a buffalo. Okay. And accordingly, you would be trying to capture the location, geolocation coordinates, right?
Geolocation, why? Why are we bothering about the geography? We did not bother about the geography. We just enough know that location where we are, that is a configuration space. The limited domain.
No, I'm a little confused for the project what you're saying. That I have taken a picture of a buffalo and I came to know that yeah, this is a buffalo which belongs to me.
That is a particular frame. We are envisioning the particular frame from the nature. That frame contains this object. That's all. Okay, we need not go for any geographical points. No need to study about the longitudes, latitudes, or GPS positions or so on. Not required.
Okay.
It's enough just see when you look at as in the perspective of a computer vision, when you look at some scenery, what do you see the objects at when they are cached into the eye image? In the eye image will be a 2D plane. The 2D plane you cannot see the depth of all the images, right? What you will see is the images are present in the frame. That's simply okay. And this does not relate to any kind of a GPS parameters or longitude or latitude. It's an image which your memory will show, eye memory will show. Okay, right?
Okay.
So in this image, what you have is several objects available, and we have a dictionary image called as .xml file, which will have the parameters of a buffalo or whatever it is. And our OpenCV algorithm will read the data from the image, the real-time image, and prepares a frame, a 2D frame of the image, like a .jpeg file, which is logically. And in this JPEG file, this image XML file will be, the parameters will be tested. Okay, tested, and they will be checked and whether that is identified in the particular 2D plane or be detected. If available, then it will simply gives a border, a boundary of the buffalo, which is green like thing and so on. Okay, That's all. Here we not worry about anything like GPS or geological things.
No, that's what I thought that you are going for GPS, but when you're talking about XML, why you want to go to XML? Because when you're using PIL and
XML, why XML? Because XML is a representation of the parameters of the objects. Okay, as I told you, the configuration of the object is very essential to understand. See, in our examples, in the 5 game simulators, what we have done for any robot, there is a quaternion, and there is a left, top, right, width, and so on, right? So these are the parameters. These parameters, how do we represent?
no,
Representing
are
them
you
with
talking?
data is
Are you
again
talking?
a not transferable
No,
form.
no,
Either we
no,
have
no,
to represent that in the dot
no,
WEBP file or dot XML file. WebP files or .xml files, and .webp files are not protocol compliant in the web environment. So we take .xml files as the compliant structures, which will represent
which is not web environment, which is not
not clear.
XML is a
Shankar,
no.
loud
You
and
mentioned two.
nearer to the
You
mic.
mentioned two extensions, right? You mentioned two extensions. What is the second? First one is XML. What is the second one? Hello, am I audible?
Hello.
One method you mentioned XML. What is the second one?
Which one?
First one is XML, right?
XML only.
And what is the second
WEBP file. WEBP file.
Okay,
Web
okay,
picture
okay.
file.
Web file. Okay.
Web P file. Web P files are there nowadays. They are becoming very revolutionistic and found everywhere. Where even a non-HTTP or non-TCP/IP protocols are also transferring this WEBP file, and they are beyond. They are becoming beyond MIME compliant. Only the MIME compliant data are transferred through HTTP and internet nowadays. But even beyond that, also the WEBP files can work.
Okay. No, because I am doing an object detection for the HTML elements, and I'm getting in the what you say in a pandas format. Means I have taken the result in a pandas format.
MP
So
format.
that
Why you have to choose this? You can go for Keras. That is a
I took
complicated.
I
Yeah,
took
image, you want to do what is called image comparison or image recognition or image processing. For all this image processing kind of activities, you better go for Keras. TensorFlow Keras is the best solution for that. You can
yeah,
directly
but
work with the images, you can compare images, you can search images, you can find a sub image of an image like a substring of a string. Okay, you can find out the replication of a sub image in a given image using Keras. You can do all these things with Keras and TensorFlow. If you go to pandas and numpy, what happens is everything becomes.
no, I'm not going to pandas. No, no, you took it the wrong way. I told that I have taken YOLO V5 and the output of YOLO V5 using PIL. I'm getting the output in panda format in a data frame. Okay.
Okay.
So I'm getting I have not used Keras over here, TensorFlow Keras. I've used YOLO V5 over here, PyTorch one. So
PyTorch.
I'm getting I'm getting it in this thing, data frame format, and you're getting an XML. So that's the reason I'm a little confused. That I'm moving to XML when we are getting a data in a simple, what is a data frame format.
Yeah, what I meant to say, this data we should not handle in our variables or carriers while doing this image processing. It is very bulky
Okay.
and they are very fragile, and there are a lot of chances of mishandling also. What happens is while comparison of the data or while comparison of the image with sub-image, something goes wrong. It is very difficult to trace back. Even our program is, even if the program is perfect, because of the data handlers, the program fails. So that's the reason why Keras has been introduced. Keras is the job of Keras is to work on the multimedia data, particularly image processing.
Okay, got you.
That's a safest method, right? Anybody else can.
Well, I think it's already 5, Sri Harsha. They've had a tiring day. So let's close for the day. Okay.
Let me see. Anybody are there? I was.
Oh, okay. Choices, yes. Okay.
Anybody are there? Please come up with any kind of proposal. We can work out on that.
Yeah, please come some kind of demonstration. Please help us with some kind of demonstration for us, since we are already discussing on top of the same topic.
We will do with.
Yeah. So next class will be probably more into that line.
Exactly.
Okay, let's wind for the day, Sri Harsha. It's
Yes,
already 5. Okay.
Thank
Take
you.
care. Thank you, guys. Thank you all.
Thank you very much. Thank you, Shani.
Thank you, sir.
Thank you, Shani.